In this video, we shall talk about a method of taking derivatives known as the logarithmic differentiation. We shall do this for the two following functions as given on this page. So let's begin. So the function that we wish to differentiate with respect to x is sine x to the power tangent x. The first step consists of taking logarithm of both sides of this equation. So log y equals log sine x power tangent x. Now we know from a logarithm that you can take the power tangent x and bring it in front of that log function. So we have tangent x log sine x. Now we can take the derivative both sides with respect to x. So the left hand side, before you take the derivative with respect to x, you have to use the chain rule. So what is the chain rule? d dx log y is quite simply d dy log y times dy dx. So that's going to give you 1 over y times dy dx. So the left hand side is solved. Now let's do the right hand side. The right hand side is taking the derivative with respect to x of tangent x log sine x. So we can do the product rule. We can use the product rule to achieve this. So the first function is tangent x. So the derivative of tangent x with respect to x is secant squared x. And then you can simply write the second function, which is logarithm of sine x, plus tangent x. Now you need to find the derivative of log of sine x, and again we can use the following chain rule to do it. So d dx log sine x is d sine x log sine x times d sine x dx. So this is the chain rule to differentiate log sine x. The result in the bracket will be 1 over sine x times cosine x, because the derivative of log sine x with respect to sine x is 1 over sine x, and derivative of sine x with respect to x is cosine x. So now you have a perfect cancellation. So tangent x, which itself is sine x over cosine x, times 1 over sine x times cosine x will simply result in 1. So what is the total result of this derivative? So the answer is, as you can see, the left hand side is 1 over y dy dx. The right hand side has two factors. One is this plus 1, because the second term on the right hand side is actually 1. So that means the right hand side is secant squared x log of sine x plus 1. Now solving for the derivative, which we are looking for, dy dx, derivative of the original function with respect to x, equals y times secant squared x log sine x plus 1. Now what is y again? Y was the original function, which is sine x to the power tangent x. So if you put that inside, you get the final answer to this derivative. And that's going to be sine x power tangent x times all the stuff in this square bracket that we have worked out. Secant squared x times log sine x plus 1. So this is the final answer to the derivative that we were looking for. Another example where we can apply the logarithmic differentiation is for this function. Let's say you have function y equals to log x to the power x. The whole log x is raised to the power x. What is its derivative? Now we can do the same. We start by taking log of both sides of this equation. So the left hand side is log y. The right hand side is x log x. Now we can start the differentiation process. Now dx of log y, so let's do the left hand side first, okay, is quite simply dy log y times dy dx. This is nothing more than just the chain rule, and that's going to give you, so this is 1 over y times dy dx. So as simple as that for the left hand side. Now let's differentiate the right hand side. The right hand side has two functions. One is x, the other one is log of log x. So if you use the product rule, let's first differentiate x with respect to x. That's going to give you 1. And then you write the second function, just like what we do in the usual product rule solution. And then you write the first function, which is x, and differentiate the second function with respect to x. So here, by using the chain rule, we get d log x, and then you write the entire function log x times d log x over dx. So this is a chain rule. So what is the second term? The second term is quite simply x. That just follows. Now this part here, d log x, d log x, is 1 over log x. It's just a usual differentiation for log. And then the last part is simply 1 over x. So this is that part over there. So this x will cancel this x, and that's going to give you 1 over log x. So the derivative of the right hand side will simply become log of log x plus 1 over log x. Now we can equate the two sides and get the final answer. So what we are looking for is dy dx. Remember that we have to move 1 over y to the right hand side. So that means your right hand side will become y times log x plus 1 over log x. Now what was y again? Now, y was the original log x to the power x, and you multiply that with whatever we have found in the step before, which is log of log x plus 1 over log x. And this is the final solution for the derivative. Of course, we can tidy the solution up a little bit so that it looks nicer, and it becomes log x x minus 1, 1 plus log x times log x. And that's the final answer to the derivative.